So now we're turning to multi-step analysis with direct effects and distal outcomes. So now, adding distal outcomes to the analysis with direct effects. What are the steps? Well, the first step is the measurement model, but in this case, the measurement model will include the covariates and the direct effects. And what should the last step look like? Well, we're going to take a look at that for 3-step, BCH, and 2-step. These multi-step analyses that were introduced in Webtalk 8. So we're going to work with the reduced ASB data, with the 15 direct effects of Model 10, adding alcohol dependence and abuse as distal outcomes. And we remember that these are strongly skewed variables with large floor effects, treated as continuous in these analyses for simplicity. And it turns out that they're likely to be correlated even when conditioned on latent class. Slide 46 then. What does this input look like for the first step? Well, we have the use variables of the latent class indicators, those 7, and the 7 covariates. And we're going to save the distal outcomes, dependence and abuse, using the auxiliary option for the last step analysis. And here we have an up seed instead of a start setting. And that's because we have done a previous run where we want to do a reordering of the classes using the S values option. So we want the classes in a different order, and this is the follow-up run to that. So what we have here in the model is C on the covariates as before, but now we add the direct effects for property, fight, etc. down. And we're going to save C probabilities and BCH weights into a final data set, and we also ask for S values here, so we're going to get the S values saved as well. So this is what I call the combined approach, where we in the first step we prepare for all 3 multi-step methods, 3-step, BCH, and 2-step. C probs are used for 3-step, BCH weights are used for BCH, and S values are used for 2-step. So now let's turn to the last step, and in this case for the 3-step approach. And the use variable list is then the covariates and the distal outcomes and the nominal most likely class indicator N, which is a hallmark of 3-step analysis. And we give starts equals 0 that we usually do as a standard for the last step. I'm going to discuss the alternative starts later on. So the model then has dependence and abuse regressed on the covariates, and we also allow for within-class covariation between dependence and abuse, since these are strongly correlated variables. We don't include any direct effects here, since the indicators are not in the model. You know, direct effects involve indicators, but that they are not on the use variable list in 3-step. They're sort of condensed into the nominal N most likely class information, which we fix down here in the logits for 3-step. So the direct effects play a role only in the first step. Let's go to BCH and its last step. Use variables are like before, except we also have the BCH weights. And using the training option, we get the weights for BCH that it needs. The model is the distal outcomes on the covariates and the within-class covariance between the 2 distal outcomes, and no direct effects since indicators are not in the model. They're not on the use variable list. All the information from those indicators are condensed into the BCH weights. Slide 49, then we have the third method, 2-step analysis, last step. And then the use variable list changes. So it's a two-step method where we fix the measurement model, parameters of the measurement model from the first step analysis. So you have them, the indicators here, property through through goods rather, and then the covariates. And again, this is the starts equals 0 situation because it's the last step. And we do dependence abuse, the distal outcomes on the covariates, and within class correlation, and input continues on the next slide, where we have the direct effects needing to be included here in the last step because the indicators are in the model. So we list them all here in the overall part of the model, and we have the C on X part fixed. And then for class 1, we give the labels for the different direct effects. We give the label for property on sex, for instance, here, fixed at the first step analysis. Give the label 29 here, just to remind ourselves that it's going to be the same as for class 2 and 3 and 4. Now it's fixed, so the labeling doesn't even matter here, but it's just for pedagogical reasons I kept them. All right, so that's two-step. Now let's take a look at slide 53 and what the results are. So the class probabilities from the first step, model 10, 15 direct effects that we looked at earlier in this talk, where we did not involve the distal outcomes. We have them here for the 4 different classes. Now class probabilities in the last step then, using starts equals 0, what we typically use, what we should use. 3 step, 4, 6, 1, 19, 1, 6, 4, 3, 5, 6. So you see the failure here. These values are quite different from those of the first step. So that's a failure, which is also seen in simulations in our 2014 paper. We have an undesirable influence of continuous distal outcomes. Now BCH, however, gives very much the same probabilities for the 4 classes. So the first and last step agree very nicely. And that's the case also for 2-step. But we're going to make a comment on 2-step a little bit later here. Now you can explore, if you want to, but shouldn't be a standard procedure, starts greater than 0. And for 3-step, you get a better log likelihood, but it's not replicated. That's bad. The class probability is still different from the first step, and you get different estimates for the distal outcomes regressed on covariates. So the solution, again, is influenced by the distal outcomes, which is not what we want. So that really knocks down 3-step in this case. BCH, same solution as for starts equals 0. That's what we want to see. So BCH is trustworthy. 2-step, you get a better log likelihood. You get the same class probabilities again, like we did there. But you get different estimates for distal outcomes regressed on covariates. So that's not what you want. Solution influenced by distal outcomes. So the distal outcomes don't follow the assumptions of the model. And we conclude that BCH is preferable, and exactly what we found in our WebNote 21 and in Webtalk 8, and it's due to within-class non-normality of the distal outcomes. They're very non-normal in their distribution, and they're non-normal within class as well, violating the assumption of the model. So BCH is the way to go here in this example. All right, so on slide 54, we look at the results for the distal outcome regression in BCH, the last step. So we have the solution here, and it concerns y on x, and it is the case where we have covariates and 15 direct effects applied in the first step, But the results here are from the last step analysis, where we have dependence on abuse as the dependent variables regressed on the covariates. We find significance for several effects, y on x. And now we're going to compare this solution from last step of BCH with the solution that we get if we only use the latent class indicators in the first step. That is, we do not use direct effects at all in the first step. So you have then for dependence, you have the same pattern of significant and non-significant effects. So for dependence, there's no difference really in ignoring the direct effects in the first step. For abuse, however, we look at the Hispanic covariate here. It is suddenly significant when we ignore the direct effects in the first step. It's a larger negative effect, about the same standard error, and it becomes significant, whereas it was not significant in the model that included the direct effects in the first step. And for H94, an insignificant effect becomes significant when we ignore direct effects in the first step. So we see that, as we mentioned early on in the talk, ignoring direct effects has some impact in the y on x regression. And in this case, it happens for one of the two distal outcomes. All right, we're now ready to do a recap of what we've done and point to some further research in this area. So on slide 56, we take a look once again at the picture that we started off with the 6 indicators of a latent class variable and 3 covariates, some of which have direct effects on the indicators. And towards the end of the talk, we added distal outcomes and looked at their regression on the covariates. So without the distal outcomes, we took a look at models that included the direct effects and models that ignored them, including the axis, but ignoring the direct effects. You could also look at models that don't include the axis, as we have done later on. We compared approaches 1 and 2 with respect to C on X, this part of the model, and found that there were some important differences in this example, as it typically would be when ignoring direct effects. And then we turn to analysis with the distal outcomes, multi-step approaches like 3-step, BCH, and 2-step, where we found that BCH worked the best. And there we looked at the alternatives like including direct effects in the first step, which is what we advocate here, versus ignoring direct effects in the first step. And here's another alternative, including direct effects only in the last step, which would be relevant for 2-step, where you have that opportunity because you have the indicators in the last step analysis. I don't know why one would want to do that particular analysis. However, I don't think it has any advantage. And we took a look at excluding covariates in the first step using a measurement model that included only the indicators, which is the standard in multi-step analysis. But adding covariates in the last step, ignoring the direct effects. And we compared approaches 3 and 6 with respect to y on x and found that there were some distortions of the results when ignoring the direct effects. Now, further research then, well, there's a lot more that needs to be known about direct effect analysis, particularly with respect to the PSEM approach. And one can imagine then doing Monte Carlo simulation studies of the PSEM approach, as has been done to some extent in Asparro and Mutean, the 2025 PSEM paper, extending the original 2024 paper to other situations, more general situations, including mixtures. And figure 12 shows how to do Monte Carlo simulation studies using PSEM. But ultimately, you may also need the Mplus automation approach, which is described on the stat model Mplus web page. And here's a caveat right now. PSEM needs to be further developed for the ordinal case, because you get into so-called threshold collapse when you include direct effects. Thresholds for adjacent categories of the indicator fall into each other and causes problems, convergence problems. But PSEM seems to right now work well for dichotomous and continuous outcomes, probably works well for count outcomes as well, although I haven't tried that yet. Now this approach that we talked about, which is LCA with direct effects, so single latent class variable, is relevant for other settings as well, including growth mixture modeling. If you take a look at the model at the bottom here, you have 4 time points, and you have a covariate x here, and you have growth factors, which are influenced by C, that is changing the means of these growth factors for the different classes, the trajectory classes. And x's influence the growth factors even within class, even conditional on class, as shown in the picture here. And you have a distal outcome here, it's a U. That would be relevant as well. This is a model that was described in our 1999 biometrics paper, and further on in other papers. This book chapter has an interesting discussion of it, of different ways of misspecifying the model. And we talk about it to some extent in web note 15 as well. So here you have the possibility, you have the effects of X on Y, but indirectly through the growth factors. So imagine that you have 10 X's here, and you have 4 Y's, then you have 40 potential effects of X on Y via S, but beyond C, so it's a indirect direct effect, so to speak. And PSEM could help you study how many of these extra effects within class effects are needed for the model and simplify the model. And that can also be done then with respect to a distal outcome in a multi-step PSEM analysis. So that's the end of Webtalk 9. Here you have the list of references. Thanks for listening.